This is the PV sourced buck boost inverter. It is connected to the grid. So the power generated from the PV is fed to the grid here using the transformerless inverter. Here buck boost operation will take place due to the switch S1. When the switch is on, it will charge the inductor, and when the switch is off, the inductor will be discharging and providing supply to the load. Here this is the DC link capacitor, and the PV panel voltage is around, for single panel 35 volt, two panels connected in series, so it will be 70 volt. Also the output is 160 watts. For two panels we will get 320 watts, and that power will be fed to the grid or load here provided here. The load is around 1.8 ohms. And this is the PWM switching technique. Here for the buck boost switch, we are providing the high frequency pulses. For the inverter, we will provide the pulses of 50 Hz. Totally, it is having 5 switches here and 1 diode inverter. 1 switch is for buck boost. The random entrance, the voltage of 75 stepped up to 270 or 280 volt. That is, first one is the capacitor, DC link capacitor voltage. Second one is inductor current. For positive and negative cycle of the inductor. Okay, and this is the output voltage, load voltage or grid voltage. Here the efficiency is around 93.5%. Okay, here when the buck boost switch is on, it will charge the inductor, and when the switch is off, this inductor will discharge and provide the supply to the DC link, and from DC link it is connected to the inverter. So for positive cycle, these two switches will operate, and for negative cycle, these two switches will operate. And as it is connected to the grid, we have to measure the THD. Here the THD is around 1.4. Okay, the efficiency is around 94%. THD is around 1.14%. And this is the results for the input voltage is up to 230 volt, and it is provided to the grid here.